In this video, we will see what raster data in GIS means to us. If I go by the definition, raster data is made up of pixels. Each pixel is associated with a specific geographical location. Raster data is an abstraction of the real world. It is used in aerial imagery, satellite images, and shaded relief rasters as the base layer when making maps in order to provide more meaning to the vector information. You can see the examples of raster data here. In the picture, the raster image is divided into rows and columns, and each cell represents a pixel, and the pixel is associated with a geographic location. The raster data can be continuous or discrete. In continuous data, there are no clearly defined boundaries. Some examples of continuous data are temperature, rainfall, and elevation measurement. And here in this image, you can see the elevation in a digital surface model. Here in the image, the data is not broken. Hence, we can tell that this is a continuous data. In discrete data, the geographic data only occurs in specific location and can exist independently. Here in the image, you can see the land use land cover map, and here the image represents the discrete data. The area in this image is divided into 5 classes, such as the cropland, agriculture land, wasteland, water body, and buildup. The spatial data can be represented in vector as well as raster data. Since we know about vector data, let us understand raster data. Raster data is a type of spatial data that consists of a matrix of cells organized into rows and columns, and each cell represents a specific information. It is made of pixels, and the value of pixel can be continuous. It is used in satellite images and aerial imagery. Now let us compare them both. The first major difference is that the raster data is made of pixels, and each pixel is associated with a specific geographic location, while vector data contains the XY coordinates and display the latitude and longitude using lines, points, and polygons. Here, I will show the difference using QGIS. Here you can see that while we zoom into a raster image, we can see that the image is made up of small pixels, and here in the vector data, the points have the XY coordinates here. We can see the coordinates position here on the map. The raster data type is continuous, meaning the data is in a constant sequence. Example, pH value, distance, etc. While the vector data type is discrete, meaning the data has space between the values. For example, the rivers, linear structures, etc. Here, this is a slope map, and if we zoom in and see, let me zoom into the map. Here, the slope map is continuous, and here there is a legend having the continuous data with the red color having the low slope or no slope, and the blue color having the high slope. And for the vector data, here we can see that these are discrete features. Another difference is that the raster data represent data in cells or a grid matrix, while the vector data represent in points or vertices. Let me show you an example. Here, if I zoom into a raster image, and here I can see square-like grids. This means that the raster image stores the data inside these grids. And in the vector data here, these points that the line meet are called the vertex. The polygon, line, and points are used to represent the vector data. And finally, the raster data is usually large in size compared to the smaller size vector data. And continuous data like the elevation map, slope map can be considered examples for raster data. And discrete data like points, lines, or polygons can be used to represent the vector data. And here, in the image here, the features marked red are the vector data, and the background map of the terrain is the raster data. The raster data represents a different way of storing the geospatial data on a computer. Some of the essential formats are here. Let us look at them one by one. The JPEG is commonly used method of lossy compression for photographic images. In lossy compression, the data in a file is removed and not restored to its original form after decompression. This data loss is very small and cannot be noticed by the naked eye. The TIFF or the tag image file format is a computer file used to store raster graphics and image information. They store high quality images. They have lossless file compression. Now I will show the TIFF file. Here you can see the file having .tf extension, and if I open this file in any GIS software, here we can see that this is an orthomosaic file, and if you go to the properties, here we can see the file format. Next is the IMG. It is a proprietary, partially documented format for multi-layer georeferenced raster imagery. It is developed originally for use with the ERDAS software. Next, we have the USGS digital elevation model, which is a popular file format due to the widespread availability and simplicity of the model. Each pixel value in this grid-based digital elevation model denotes spot elevations on the ground. Let us open the digital elevation model file. And here I am coloring the raster image. Here we can see the elevation in continuous data. The grid is a raster file format developed by ESRI and as a proprietary binary format and a non-proprietary ASCII format. The binary format is used in the ESRI software such as the ArcGIS, and the ASCII format is used as an exchange or export format due to the simple and portable ASCII file structure. The portable network graphics or the PNG is a raster file format that allows lossless compression. Lossless compression reduces the file size without decreasing the image quality. They are designed for efficient viewing in web-based browsers such as the Internet Explorer, Firefox, and Chrome. Now, I will show you a PNG file. You can see here that the file is having a .png extension, which means that this is a PNG file. Here, let me open this in a GIS software. This is the PNG file. And here, if you open this file and if you go to the properties, we can see the file format here. Now, let us have a quick recap. First, we discussed what a raster data is, then the types of raster data, and the comparison between the vector and raster data, and finally, the different raster data formats. So, this brings to the end of the video. I hope you gained some knowledge on raster data in GIS. If you are watching this video for the first time, please like and subscribe. And we will be sharing more videos weekly. Click on the bell icon so that you won't miss any of the upcoming videos. And thank you for watching the video.